brief overview of what like we'll be touching upon today. So first we'll go through kind of an introduction on what competitive programming is and what IEEEXtreme and more extreme is all about, and then we'll share how you guys can get prepared and like the things that we do to get prepared and things that we think you can adapt into your preparation as well that would be beneficial for you in competing these competitions. And then finally we'll share some of our experience and the strategies we use during the competition and before the competition as well. So before I start, I kind of like to get an idea about like the audience that we have today. So can people from 22 batch like raise your hand? 22 and okay, great. So there seems to be yeah a good proportion of people from 22 batch. So okay, so I'll spend more time on the first parts and and I think everybody will be able to follow along and use whatever we share in their preparation as well. So it's I hope you all can see my screen. Sandil, can you confirm that?
Yes, it's visible.
My screen is visible. Okay, great. Okay, so yeah, so I think as you all know, IEEE and more extreme are two biggest competitive programming competitions. So we'll start with what actually competitive programming is and why would you or anybody else should care about it. So competitive programming is basically, you can think of it as like maybe like a mind sport where like a set of people spend time tackling or solving programming problems in like a given period of time. So like a programming problem would be something like this. So here you can see like an example problem. So in this problem, what like we need to do is given like some amount as the input and the available set of yeah, given some input, given some amount as the input, we need to find the number of ways that we can make that amount using like coin change, the amount of change that is available. So like a programming problem is something like that, like you will have like you will get some input and then like you need to generate some output, and that whatever the program that you write to generate the output from the input needs to be execute in a like a certain period of times. For an example, let's say in like less than 1 second, whatever the however big the input is, you need to make sure the program that you write is efficient enough to generate the output within around 1 second. So that's what competitive programming is. And so why should you care about competitive programming? Why should you do it? So doing by doing competitive programming, you actually sharpen or like sharpen your skills in 3 areas. So you will increase your problem solving skills, critical thinking skills, and efficient coding skills. So the competitive programming is a great like a platform to improve all those 3 skills, and those skills are vital in engineering practice because at the core of engineering, what we have is like problem solving. So by doing competitive programming, you are basically enhancing the core skills that you need to do. Uh, you need to be a good engineer. So and these the skills and the experience that you gain by doing competitive programming really do get used whenever you are doing engineering projects. So if I give a brief example from like one of the projects that I did. So like we did a project where we designed a set of smart glasses to um, for people suffering with photosensitive epilepsy. And in that, what we do is we have a camera in the glass and we take the input from the camera and we identify in each frame whether it's a epileptic trigger or not. So when we first designed it, the frame rate of the device was around 3 seconds, which is very, very slow. So like since like the team members of that project were well versed in competitive programming, and we have dabbled in optimizing code and increasing like the efficiency of the program. We were able to, like, without altering any major changes in the algorithm, we were able to optimize the code and improve the frame rate by around 200%. So that's like an example that like experience that I had of like a practical usage of the skills that I gained from competitive programming used in engineering. So IEEEXtreme is like the most prestigious global competitive program competition that there is, and it will span for 24 hours, and you will get a chance to compete globally and see how well you match up with like the global talent per se. And of course you will also get the prizes for if you make it to top 100. And yeah, so these are some of the metrics from last year's competitions. So there are participation from 65 countries and total around 14K participants. So you can see that it's a quite big competition where you will get the opportunity to compete globally and improve yourselves, because it will be a tough competition. So by like competing in a very tough competition, you will improve yourselves in like 10 folds if we like yeah. So apart from IEEEXtreme, More Extreme is like another competition that is like a very big national competition that there is for competitive programming, and it is held annually along with IEEEXtreme. So it mimics the model of IEEEXtreme, but it spans for 12 hours instead of 24 hours. And as I mentioned before, it's like good competition for you to compete locally, and there'll be prizes for the top 3 winners. And I think this time it will be held on 27th October. And it is actually a very good competition to practice for IEEEXtreme as well. So we as a team, we have participated for like, I think 3 years in a row now. So in each year, before we participated for More Extreme, and found out in our competing extreme is really, really valuable for our performance in IEEEXtreme, because you get a kind of taste on what kind of challenges you will get as a competition in IEEEXtreme, and how to deal with it. So like you will basically get a trial run before the IEEEXtreme in More Extreme by competing in More Extreme. So I think both IEEEXtreme and More Extreme are good ways for you to participate in competitive programming. So now, since you know about the 2 biggest competitions there is, now the question is, how do you get prepared? So I'll start this process from explaining from like a complete beginner who doesn't know any programming. I'll explain the process from starting from a person who doesn't know any programming to go to a level that you can be very competitive in this global arena. and you guys can evaluate yourselves and see which stage that you are in, and you can start to follow um, and you can start to follow from whatever the stage that you identify yourself to be. So if we start from the very like the first level, so first what you need to do is like get proficient in like one programming language. So you don't need to know like a lot of programming languages for this. Like if you are a person who knows who know like a couple of programming languages, what we recommend is like choose the one that you are most comfortable with and the one you have more experience in, and use that as the primary programming language of choice when doing this competition. And the reason that I say the uh, the programming language that you use for the competition does not matter is because of the structure of these kind of competitions. So if we like take Python and C++, C++ is around like 10 times more faster than Python as a purely a language. That is because C++ like uh, like basically like Python is written using C++ as well. So everything in C++, like you have to do stuff like some of the stuff your own, and like it's very like on a, you can say on a low level. So that's why it's very fast than Python. So if we consider just the two languages, like the C++ is like 10 times faster than Python. But the reason that I say like a person writing in C++ and person writing in Python both have the same competitive like edge on each other is because in both IEEEXtreme and more extreme and any other competitive programming competition, the like the runtime limitations. The runtime limitations means how fast like how fast your for like the basically it's like when you give the input how much how much they allow you to run your program until the output is generated. Basically the runtime of the program is catered case by case for languages. For example, if you provide a C++ solution for a particular problem, they will expect your program to complete within like 1 second. But if you write a program in Python for the same problem, if you write the program in Python, what they expect is around your program to be concluded in around 10 seconds. So they like account for the inherent difference in speeds in different languages, so that person competing in one language does not like necessarily get a disadvantage because of the inherent like slowness of that language. So basically the reason that they do that is because they want to test your like basically your problem solving skills and not your like ability to use a language, but rather how you can solve a problem in like a creative manner. So yeah, so we recommend that you get proficient in one programming language, and if you have several programming language that you know, pick one, and you like pick one, the one that you are most comfortable with, that you have most experience with, and use that as your main programming language um, in the competition. But with that, we have to mention in our experience, what we do is we mainly write using Python, and as a secondary language, we use C++. And the reason that we say we use it as a secondary language is like there are some instances. For an example, let's say there's like a program problem and you implement a solution, and then for around 9 test cases, your solution passes. And for the last test case, it says a timeout. Let's say I wrote the solution in Python, and for 9 test cases, it's passed. For the 10th test case, it like times out. That means like you haven't, like your program is not within the time limit that have been specified. So sometimes in like rare cases like that, there is like a small possibility if you write the same algorithm in C++, something like in C++, it might pass all 10 test cases. We have personally experienced this in IEEEXtreme competition, both last year competition and the year before as well. But this is like very rare incident, not like you cannot do this for all the programs, sorry, all the questions. Like this happens in like maybe like one question for the whole competition. But if you encounter like a scenario like that where all of the test cases except one gets uh, timed out, like sorry, only like one test case gets timed out and other everything else is fine, maybe this is something that you guys can try. So then once you get like proficient in one language, so this is like if you are a beginner and you start now and you get proficient with one language, that you like learn the basics and like learn how the language works, we recommend that you uh, start solving programming problems with the knowledge that you currently know. That means like the knowledge of using the language. So uh, you can like you use sites like CS Academy, HackerRank, LeetCode, Projectula, and Codeforces, and there are many more sites as well. And these are some of the sites that we have used. And these sites contain programming problems similar to what you would get in both IEEEXtreme, or Extreme, or any competitive programming um, competition. And you can like go to these sites and solve the problems that they have. So the reason that recommend that you start solving problems as soon as you get somewhat proficient in a language is programming is a skill that improves with practice. Like no matter how much you like theoretically learn the different ways that you can learn the language, you will never use it, like you will never actively use it until you like practice it, because otherwise it will just, you will forget about it in a couple of few weeks, and basically the time that you spent basically learning won't be basically useful. So whenever you whenever you get proficient with a programming language, you should like practice with it to actually be good at it. So when you do that, you will come to a point where like you think of very smart ways to do like solve problems, but when you implement it in like the uh, language of your choice, uh, it like works, but it will not work in the specified time limit. So that means is you have found a creative way to solve a particular problem, but uh, your like the method is not efficient enough to efficient enough for what they have required. So in when you start like constantly experiencing those situations, that's a time for you to go to your next step. So next step is learning about the big O notation and data structures and algorithms. So yeah, like in this session I won't have much time to go into like deep into these like sections, but I'll give you a broad overall idea, so that after this session you can go and explore on your own, and you will have a path for you to follow. So the big O notation is basically a method to determine the uh, the method that you have found as a solution. Like it's a basically a method to determine how efficient.
Now it is sorted.
Yeah. So big O notation is like basically a way to determine how much efficient your method of solving the problem. So if you like design an algorithm to solve a particular problem, if you like use the big O notation and method and analyze that algorithm, you can determine how fast, like how efficient your algorithm is. So by that you can get an idea whether like whether like whether actually this particular algorithm can be how it can be like improved more. Like if it is like even before implementing the solution program and running it, you can like get to know whether this algorithm would be efficient enough for the current problem or not. uh, yeah, I think the way I'm saying it might be vague. The reason for that is like if I have to like be more specific, I'll have to go much in depth into it. So I like recommend you and like search for big O notation, and there are plenty of good resources on the internet to learn about it as well. And after learning the big O notation, you should learn data structures and algorithms. So data structures means different ways how you can like different structures to basically store your data, so that in like different instances, like a particular way of storing data would be beneficial than the other. So like uh, yeah, so it's like basically efficient way of storing data and retrieving data. Something you can think of it as something like that. And algorithms are basically like smart ways that people have like already derived for like common problems. For an example, for like shortest path, let's say you for an example, like a shortest path finding problem, there are like plenty of smart ways that people have already developed, and like you can learn about them, and like you will then you will be able to like use them directly in problems as well. And also you will be able to like get inspiration. Like inspiration means get the core idea what they have done, and like why the method that they have implemented is working. You can get that idea, and maybe you can implement like use that idea to solve another type of problem. So something like in a like instance like this. So both data structures and algorithms will ultimately help you in um, improving your inefficient solution. So how like big O notation and data structures and algorithms would fit your uh, process is like initially when you implement an basically a method to solve a problem, but it is not efficient enough. Using the big O notation, you can measure how what's its efficiency, like or how like yeah, what's its efficiency or how inefficient it is, and then you can use data structures and algorithms ideas from those two to improve the efficiency of whatever the solution that you have implemented. Yeah, so these are like you like commonly like used data structures and algorithms. For example, this heap and priority queue is like very useful in our team. We use like a lot of times during the IEEE competition. Like basically you can like just using like switching out a normal list that you are using to a priority queue or like a heap, you can like uh, increase the efficiency of your algorithm like uh, maybe 10 folds or even more than that. So like it's a very useful one. And other than that, there's disjoint sets, graphs, uh, sets and hash tables and trees. So like disjoint sets are like basically um, yeah basically like sets that do not have things in common. And like graphs is like you have like a node and there are like paths connecting nodes, and hash tables are like key value pairs, and trees also like something similar to graphs, but yeah, but like these things you can like go on your learn about that, because we don't have time today to go deep into data structures, because it's like a very huge area. But here we have outlined like the useful data structures in our experience, from our experience that we use quite a lot, so that you can go and learn about each of these uh, from the available data structures. And coming onto the algorithm side, the shortest path finding algorithms, that's like a very key set of like uh, algorithm class that is heavily used in like competitive programming competitions, like in general, and of course in IEEE Extreme. So there are like algorithms like Dijkstra's algorithm and Bellman-Ford algorithm, and you can learn about those as well. Like we'll share some resources how you can learn about these data structures and algorithms. And there's like a dynamic programming. This is also like a very big area that is tested in IEEE Extreme. And so like dynamic program basically means like solving optimization problems. That's basically dynamic programming is. And there are like graph related algorithms like spanning trees, and those like get more complicated. So what we would suggest is first you like learn the shortest path algorithms, then like learn a bit about dynamic programming, then you can go and learn about graph theory related algorithms. Because in IEEE Extreme, like most of the questions that you get are related to like uh, basically graph problems that include shortest path things as well, and other ones are optimization problems. So those are like dynamic programming problems. So like having an understanding of algorithms in these domains will be very useful in solving those problems. But like I have to mention here that you won't be able to like flat out like use the algorithm in like let's say there's some algorithm uh, uh, let's take like the shortest path example. Let's say there's like a shortest path algorithm called Dijkstra's algorithm. You won't get like a problem where you can just use like the Dijkstra's algorithm and voila, you get the answer. It will be more complicated than that, but the Dijkstra's algorithm will play some part in like your solution. So it's not like the entire thing, but it will help. Maybe like the Dijkstra's algorithm itself won't be useful there, but uh, according to the problem, you can like creatively make changes to the algorithm and then use it. That is like you use the core concept, but with like creatively tweaking the algorithm to like get as a solution for that like particular problem. So just to summarize, understanding of data structures and algorithms is very vital, and it is like you won't be able to do it. I mean, these data structures and algorithms is like a very wide, like huge area. So like don't like expect to cover everything by like week or two, but and also you don't need everything for to like perform well in like IEEE Extreme as well. So if you get a good idea about these data structures we mentioned here and some of the algorithms in these areas, you will be very well prepared to participate in IEEE Extreme and really do well. And like getting acquainted with these data structures and these like algorithms we have mentioned here is like a very doable task in a week or so. Yeah. So this is like a very good resource that you can use to learn about uh, like data structures and algorithms, and like it will cover big O notation as well. So like this competitive programmers handbook by anti Leikonen is like a very good book, the book that I have personally used as well. and it is, I think, freely available on the internet as well. So we'll share this link for you. And the other one is this cpalgorithms.com. This is also is a very good website that you can use to learn algorithms. And like how I would suggest to use these two resources is, first you use this competitive programmers handbook to learn about uh, the algorithm. So let's take, you want to learn an algorithm. So you first use this competitive programmers handbook to learn about the algorithm, and then you try to implement it. So like when you go to implement it, it won't be like very easy, uh, like uh, like it the implementation won't be like very straightforward. You will definitely hit some bumps, and but try on your own and try to implement it, and try to get it to a point it's working. Then after that you can go to the cpalgorithms.com. Here they have like outlined how they have implemented, which is usually like the, let's say, best way of doing it. So then you can see how they have implemented it, and then like kind of uh, like learn from the mistakes that you did during the implementation by looking at their implementation. Yeah. So then after you get familiar with data structures and algorithms, you should get familiar with built-in libraries. So this is actually specific to Python. If you are using other programming language, uh, I'm not sure whether this will apply. But if you are a Python user, this will be very useful. There are like very beneficial libraries. Like this iter tools is like to generate permutation and combination. So any programming problem that has combinatorics problems, you might be able to use this library. And this collections is very like a useful library. It has like implementation of different data structures. So since it's like a Python library, it's like the best, mostly like the best possible implementation. So you can use different data structures there. For an example, they are defaultly counted those things like that. And this heap queue are also Python implementations of queues and priority queues. So as I mentioned before, we use priority queues a lot during our competition, and we always use heap queue for that. Instead of implementing the priority queue data structure ourselves, we use the heap queue, which is like built into Python. And you can, there's like func tools, bisect, and all of these libraries you can learn about in the internet, because there are so many resources there, since Python is like a very popular programming language. Yeah. So then the fourth one, which is a step that nobody can fully complete, is like practice continuously, because when you like practice, that's how you like develop. Because you will come to some point that you have done all the previous steps, but each time when you practice, you will like learn something new, and you will be more proficient in solving problems, and you will feel like you will be able to do it faster, and you will feel more comfortable, things like that. So practicing is like a very vital part here, and you should like practice as much as possible before the competition. So so a point about practicing. So since both IEEE Extreme and more extremes are like team competitions, first you should like practice individually. For those, you can use like the site we mentioned before, as like HackerRank, Project Euler, uh, and yeah, so sites like that you can use to practice individually. And you should then, after practicing individually, and like when it's like near the competition, you should we recommend that you like practice like competing as a team. So to do that, you can use this site called codeforces.com. They hold like mini team competitions, uh, for like I think like around 2 hour like competitions where the team like as a team can like try to solve all the as I remember around 6 problems that there is in the given time frame. And like we in our experience we have found that it is a very good way to like test the strategies to like test the strategies we plan on using during the IEEE Extreme competition. That means like how are we what's the strategy on dividing questions and things like that. So those things like you can uh, like put it into practice before the IEEE Extreme competition and see how those strategies like when working as a team would pan out and how effective they are. So this is a very I think a good resource that I think all should use before participating in the competition. Uh, yeah, and like there are like competition strategies and like the experience that we have gathered during the past 3-4 runs of participating in IEEE Extremes. And yeah, Anuki from our team will uh, talk about that. I think Anuki is currently experiencing some technical problem. Let's wait for her.
Can you hear me?
Yeah, we can.
Okay. So I'm really sorry I can't turn on video at the moment because I'm in a dark place right now. So can you go to the next slide? So I'll be talking about the strategies that we can use during the competition and before the competition and things that we used as a team. So before that competition, we divided the main areas of problems that are asked in the competitions like Mora Extreme and IEEE Extreme among the 3 members in our team. So as Supun also said, a lot of problems are asked about graphs that involve graphs. So that's one main area. And also there are lots of dynamic programming problems, that things that ask you to find maximum, so minimums, things like that. And there are other categories like also things that involve mathematics like combinations and permutations. So there are several areas of problems, and we divided those areas among ourselves because we it's difficult to do all things by all of us. So then we by doing that we can divide the problems that we get among ourselves. So if it's a graph heavy problem, one person will do that. So we made a plan like that, so that we can efficiently divide the our knowledge without everyone having to be perfectly aware about every part of competitive programming. And before the competition, we also refreshed our knowledge about these areas that we have chosen, and then did some problems to warm up ourselves with these data structures and algorithms. And one useful thing that we did was to keep some algorithms and some data structures are a little bit lengthy and tedious to implement. Like trees, something thing I have found useful is disjoint sets. So what we did was we implemented this before the competition, and then we keep those codes saved so that if there's a problem that you think you might need that data structure or that algorithm, we can directly use that. So I think it's better than copying code from the internet, because you already know every part of the code very well. So because you don't get to directly apply any algorithm in the competition, as Supun said. So you need to be able to know every part of that code to be able to change things that and tweak the algorithm the way you want. So keep some of your implementations saved so that you can easily use them during the competition. Can you go to the next slide? So then during the competition, so there was a choice to whether to participate, get together online or physically during the competition. So there are pros and cons to both of them. So online, both IEEEXtreme and IEEEXtreme start very early at 6 or 5:30 a.m. And so it's difficult to travel if you are not near the university. So and also doing it from home might be more comfortable because it's a long amount of time. But it's also the cons are that there might be connection issues and you can't really talk properly sometimes. On the other hand, if you join and get together physically, it's very easy to discuss things with your teammates and do things together. So it's up to you, your choice on what's easier for you. What we chose was online participation, mainly because it was difficult for us to travel. So how we use the online method was we use Discord channels to discuss with each other. So when we are doing a problem together, we made a separate Discord channel so that the other person won't get disturbed. So then for brainstorming and talking about, like sometimes you have to write something out, draw something out, you use the Miro board for that with so that we can share our thoughts with others. Next slide. And so you have a long time span in these competitions. So you need to be able to utilize your time effectively. So we always started right at the time, even though it's a bit sleepy. So we went to bed a little bit early and started on time, because then it's less pressure, because otherwise you feel like your other people have already started and done a lot of things before you, then you are under a little bit more pressure. So when you start on time, that pressure is a little bit less. And also when we needed to take breaks, we did that in shifts. So when one person went to take a break, the others will still be doing a problem. We planned that out for taking naps as well, but luckily we didn't need to take any naps, only food breaks. And an important tip is that if you have been trying to do one problem for a long time, you are trying to find a solution, but you can't, then keep that there and move on to another problem and come back later, because then one thing, you will save some time if the next problem is easier. And the other thing is, sometimes you might think of a better solution when your mind is fresh, and maybe you might have gathered some ideas from the other problems that you did. So that will be useful to manage your time. Next slide. So now I'll talk about some tips that can be used when solving the problem. So when reading the problem, before you try to think of a solution to that, look at the constraints that are given. So all the problems will have these constraints. So you know, most problems have things like you have to do something with an array of in numbers. You have things like that. So your solution will depend on what that n is. So if the n is small, you might go with a very naive brute force solution. But if that n is very large, you will have to think of a more optimal, efficient solution. So how do you decide what to do? Like, you might waste your time thinking about efficient solutions when that easy solution would have worked. So you can try to decide that by looking at these constraints. So I have given some examples of constraints here. So in this one, so these numbers will obviously depend on the question, but I think this n means something a length of an array or something. So that is less than 1000. So Supun told you about learning about big O notation. That will also be useful here. So a sort of a rule of thumb that we use is that when you plug this number into your big O notation, if you get about 10 to the power 7, above that, it won't be efficient enough. So for example, here, if you have an O of n algorithm, that's basically if you don't know big O notation, that's basically like one loop across all the n things. And n squared means like two loops within one another. That's a simple idea. So if you have a big of n solution, that means when you plug in 1000, it's 1000. And here you have to think about if there are several test cases in the problem, there's 10 test cases, it's 10,000. So that's less than the 10 to the power 7. So that ON solution will be enough. And in this case, even ON, if you take ON squared, it will give 10 to the power 6 times 10 for if there are 10 test cases. That will give 10 to the power 7. That will also be all right. So if for this problem, if you have n squared solution, that will probably work. For the second one though, it says that something size of something is 10 to the power 5. That one, if you take n squared, it will be 10 to the power 10. So that won't be efficient enough. The n squared algorithm won't be efficient enough in that case. So you might have to look for something like n log n or for a problem like that. So that's why you need to know about big O notation and how to find the complexity of your algorithm, so that you can get an idea from these constraints about what sort of solution you need. Next slide. And this is another thing that used a lot. So a lot of time this happens, your solution works perfectly for the given test cases, but it fails for some hidden test case. And so sometimes you get a runtime error for that hidden test case. So HackerRank and the site that IEEEXtreme is hosted on, both of them show failed, wrong answer and runtime error separately. So you can identify what has happened, but you don't know where that error is because you don't get it from your known test cases. So what you can do to figure that out is you can add try except statement. So here I have shown an example of that. So in this code, this BFS function is where the main computation happens. So I have added a try except statement there. So basically that means if you get an error in this BFS function, it will skip that. So you won't get an error when you do that. You obviously get a wrong answer, but then that hidden test case will show wrong answer instead of runtime error. So you know that the BFS function is where the error is. So if you still get a runtime error here, you can try adding try except at a different place and see, then you can narrow down. So even within that BFS function, if you find out in this method that there is an error here, you can put try excepts within that function in a smaller block of code, and like that you can narrow down where your error is occurring using this method. And also if you really narrow it down but still can't find out what there is, you can add except the type. For except in Python you can specify the type of error. So like value error, those things you can also add to narrow down what sort of error that you have. Next slide. So this works because you are allowed unlimited submissions, so don't worry about submitting again and again. You can take advantage of it and debug your solution. Next slide. So we in these competitions, we work as a team to solve these problems. So we also had a strategy for that. Initially, the problems that you get are relatively easy. So the three of us chose 3 different problems and started solving them. But then when we got a hard problem, first we implement it individually. But when that fails, we talk with the other 2 and we get together to discuss that problem. And then we use the Miro board and brainstorm possible solutions. And then if we find a solution, then again one person will implement that and the others will go back to either discussing another problem or doing something individually. So then that's the method that we thought was the most optimal to make use of all our skills. But that might change depending on your team. So again, it's your choice to pick a good strategy for tackling problems. This is what we did. So so to inspire you, we thought of talking about some past success stories of IEEE Extreme. So it's a really large global competition. So reaching the top 100 or even 200 is a big achievement. So we managed to become 87th globally, and the second and third teams in Sri Lanka were also in the 126th and 127th, which is really impressive. Supun, can you explain from here?
Yes. Yeah, so as Anuki mentioned, here you can see the previous year's results, and like each year, like these results around three teams break into like the top 100, and yeah, as Anuki mentioned, since this is like a global competition around with 14K participation. It's like a quite hard thing to do. But what I have to mention is uh, it is hard, but it is entirely doable uh, because like as you guys, I personally have been in a session like this 2 years back, done by a person like a Maivan Naya, who was like a top ranker in that year, and I was just starting out. And that year itself, this team, like we were able to break into top 100 that year as well, and in the last year as well. So like like what I have to reiterate is it is very doable. We were able to do it, and I think you are also very capable of doing it. And I'm sure maybe a team that is participating in this session might break into 100 and this year. And if that happens, like I'll be really happy. And I think that is very possible thing to do if you guys practice and incorporate some of the tips that we told that you think would improve your efficiency and you improve your overall performance. If you do that, you will be able to break into top 100 this year itself. And apart from that, there have been like 2 very special achievements that have been done by our undergrads. So the photo here, you see like a photo from the IEEE competition from I think 2014. This team was able to become global third. In like that means like third in the entire world in the IEEE, and this is like uh, I'm not sure whether this is a photo from the actual team, but like this is a photo from the IEEE competition, I think in 2009. So it's like in that year, a team called Mora Seekers were able to become the global number 1 in IEEE Extreme. So 2 teams have like broke into like the top 3 and basically won the competition as well. So it's a very hard but like a possible thing to do to achieve global a very good global rank in the IEEE Extreme. So I invite every one of you to take part in this this year IEEE Extreme and this year more extreme as well, because it will be a very good practice for you to for IEEE Extreme. And if you work from today, and if you yes start working from today, you will be able to have some success in IEEE Extreme this year as well. And by continuing to work even more, the next year definitely will be get a very good ranking, maybe even 1 or 2 as well. So yeah, I think with that we can yeah, that's all the what we have to convey to you guys today in this session. And we are open for any questions. Let's see. Okay, great. There are a lot of questions. I like it. So let's start from the top. Are there any particular IDEs to use in the competition? So yeah, for our team, I think we use different IDEs. So yeah. So yeah, let's actually a choice of ID is actually a good thing that you can smartly think, because the most important thing is how well it supports debugging. For me personally, I typically use VS Code, but I find that it's debug is very well capable, but it's structured, since it's very in a very cramped space. I find it very hard to um, uh, debug using that. So what I personally found was a very good IDE for me during the IEEE Extreme is like a IDE called Spider. Uh, yeah, this one. So here, the reason that I like it is you can debug very easily. Let's see, still loading. Yeah, so this is like a IDE designed for data science stuff, but it's from other use. What we experienced was this is very good for computer programming stuff as well. The reason is its debugger is very good. Like here you can, when you put breakpoints and when you do debugging, using this variable explorer, you can see everything. And yeah, everything. And there's like a IPython console here. You can evaluate anything as well. So this is one thing that we have used. And there's I think PyCharm ID is also very good at debugging. That's maybe something that you can use. And actually VS Code is also very good. It's like a personal preference. It's not like a right or wrong answer. Um, a personal preference. So that those are some of the suggestions. Spider, maybe PyCharm, and also VS Code, and yeah, those things. Cool. Yeah. Chamaru, can we tick off the ones that we answered?
Sure thing. I'll do that.
Okay, thanks. Okay, then practicing is a must when preparing for the video. Do you have any ideas? How should we practice? Yeah, so what we suggest is first you practice individually using the sites we mentioned in the in our slide set. We'll share the slide set as well. So you can use HackerRank, Project Euler, and there are many different sites like that that you can use. and and lead code. Yeah, lead code is also very good. And then maybe you can try the platform that the IEEE competition is held, like the if I'm not mistaken, it's called Code Academy or something. And yeah, and then as an additional thing is what I would highlight is to practice as a team. That is like to use the code forces side and like do it as a team. You can like participate individually as well. You can do it participate individually as well. It's like a very good site. I personally find it to have like a very like good questions. So initially you will get some few easy ones, but then suddenly it becomes quite hard. So you can like try using that, and uh, I think that's a good resource that you can use. Does all the team members have to know the same programming language programmer? In our team, only one member knows Python well, and other two knows C++ well. I think people knowing the same language will have an advantage. The reason for that is so in experience, in our experience, what we have done is, let's say I implement some try a program problem, and like implement a solution, and suddenly there's something wrong. Maybe a test case doesn't work, or uh, or there's some timeout issue or something like that. Then what like after trying it, giving trying to using my own, I think that is not seems to be getting me anywhere. What we would what I would do is I would ask one of the other members to have a look at the code. Then if they are like using this know the language quite well, then like they'll be able to easily go through and see. And like so in that case, I think knowing the same language helps. But yeah, I think it would help, but I don't think there's anything wrong with like having a team composition like this as well. Because you might can utilize some other way of debugging, way of debugging instead of that. So other than the thing that I mentioned now, I don't think there's any problem with people knowing different languages. But I think if they knew only like one language well, that would be somewhat of an advantage. Yeah. Can we use the internet during the competition? For an example, look at Stack Overflow. I think, yeah, I think you can look at the internet. Uh, Copy and pasting code, I'm not sure actually. Anuki, Bimsara, do you have any idea on that?
For IEEEXtreme, from last year, they have said that you are allowed to copy paste, or you are allowed to use the internet as you wish. But about copy pasting, they have mentioned that you can copy paste, but give the source in the code. But just to be sure, we don't normally use code directly from the internet, because there might be plagiarism issues and we don't want to risk that. But I'm not sure this year whether there are any new rules because of AI related things. So I think from IEEEXtreme, the organizers will clarify that.
Great. I think that is okay. Then how frequently we get problems like one question per hour, like yeah, if I remember correctly, it's something like that. But initially we'll have like a set of questions, let's say around 5 or 6 questions, and then like each hour, like a new maybe like new question, or maybe sometimes around 2 questions get like appear at the same time. So yeah, something like that. Like you won't have the entire set of questions at the start. You will only have like around a small number. Then like each hour or so, you will start getting more and more problems. What is the AI policy of the competition? This actually we don't know. I think maybe if there's anyone from the IEEE Computer Society have any idea?
Uh, yeah. So when it comes to plagiarism, actually, it's fine for you to copy a code from internet, to be honest, but you should give your like credits. But in case if we see that you have copied from one participant of the competition to one another, so then it's going to be a problem. Actually, we are using like a plagiarism checker called MOS to check like individual like participants' codes with each another. So if you have plagiarized from like stolen code from one of the competition members directly, then we'll get you code. And when it comes to IEEE, I think there's such mechanism as well. So I'm not 100% sure about like their plagiarism checking mechanism, but when it comes to AI, I think there's no way right now to like exactly say whether this was like generated by AI or not. So I think that won't be much of a problem. Yep.
Okay, great. Yeah, there go your answer. And are you guys participating this year as well? Yeah. Yeah, like since this is like our team's last year, we are trying to give it another go. So hoping tough competition from you guys this year. Can we get the slides for the session today? Yeah, I think uh, we can like distribute the slides. Chamar, is there any? We can distribute the slides, right? Yeah.
Yep. I'll include them in the group. So if you haven't like
Oh,
joined the WhatsApp group, please do so in the meantime.
okay, great. I'm a student from a private university. Currently, I don't have strong knowledge in data structure algorithm. How can I improve my skills? Great. Like what I suggest is you start using the book, the one that we mentioned, Competitive Programmers Handbook, and it's like very digestible. But like, of course, you will feel come to play like encounter places where you actually don't clearly understand what they say. In that case, you can like prefer YouTube on that particular maybe algorithm or this thing that you don't know about. But I like suggest you to use the Competitive Programmers Handbook as like a guide. Yeah. And there's another good book as well. It's called Introduction to Algorithms, if I remember correctly. Let's see. Yeah, this one. Yeah, this is also a very good book I have used. You can like try this as well. But I personally feel the uh, Competitive Programmers Handbook is very digestible than this one. So you can use that and use the site that we mentioned, CP algorithms, to like explore further. And if you do those things and practice, that's a core component, and practice, and like whatever you learn, you should like implement it in a problem and like get familiar with it, because you won't know the things that you like quite necessarily get in a like quite necessarily that you don't 100% understand an algorithm without doing a problem. When you do like actually do a problem and implement it, you will have to like think through the entire algorithm on how to use it for that particular problem, and then you will then you will like after implementing it, you will like have like in and into out understanding about the entire algorithm. Is there any way to get the recording of this session afterwards? I think it's a question for the organizers. Chamaru, any comments on that?
Yep, we'll definitely share.
Great. what is the programming language you used in IEEE? Yeah, we primarily use Python. That means like for whatever the problem we think of like a possible solution, we will and we use Python to implement it. And if like it hits the place where if we encounter a like a place where like you have 10 like 100 test cases, and 99 of the test cases the Python implementation works well, and on the 100th test case there's it's like a timeout error. In those instances, which is like very rare, trust me, very rare, and in those instances we use C++ to implement the same algorithm and try it out, and like from our experience it has worked a couple of times. Still, I do not have an IEEE membership. How can I get IEEE membership to take part in IEEE? Yeah, unfortunately, you do have to pay. How you can get it? I think you just have to go to IEEE site. Let's see. Yeah, I think you have to go to this IEEE site and make an account, and then yeah, and I think you can like the process is, I think, straightforward. But if you get any issues, I think like the organizing team from Moroto will like give you a hand in that. I think if you have any problems, you can contact them and get like clarifications on like the way. But you will have to pay. But you like this for like, since it's for the student membership, it's not like the full amount for like the full IEEE, I think, membership. But still, you have to pay. It's I actually remember them. You have to pay some amount. I would see had essentially no formal CS education. I think so. Like you will have to learn a programming language separately and like be fluent, but like the computer science concepts you will be able to learn from the handbook and CPU algorithms and this introduction to algorithms book. This is actually like a book, I think, from MIT, and in the data structures and algorithms module that that was done for me, like for us in like in our university, or like they use this book as the reference as well. So I think you can use that book and CPU algorithms and the handbook to get a good grasp on like actually really learn these algorithms and data structures. But fluency in the programming language, you need to get it from other sources. Yeah. How to master DSA? I think since like the problems before that also covered this one, we can skip it. Do we have to create an account or make a membership via IEEE website before participating? Yes, you need to make a account and have membership to participate. It is like a mandatory requirement that they have. What are the advantages of ACT's competition team-wise or participate? Yeah, it's basically like the numbers. The numbers in the sense, in the team, you will have 3 people who will be attempting to solve like, yeah, so yeah, so in the IEEE competition, it's very hard to like finish all the problems, in the sense they will be adding and adding and adding and adding more problems. There will be like a lot of problems. So realistically, if we think realistically, like even a team would not be able to finish all the problems because there are a lot of problems. And so if like 3 people participated, so from like let's say we have like, for example, there are 100 problems and 3 people attempt the 100 problems in the given time, and only 1 person attempts all 100 in the given time. So in this case, purely due to the numbers 3 against 1, like the team will be able to get more done or more questions done in the given time frame. So ultimately they will get a more score. That's the the difference between participating individually and as a team. How many years can you participate in activities? Can we take part every year during undergraduate? Yes, you can take part every year during undergraduate. but after you are done with your undergraduate degree, then you cannot participate. From my knowledge, that's how it is. What are the antecedents? I think these two we covered. Is the number of challenges that we need to be solved that need to be solved writing up proportional to the number of no, like even if the team has 1 member or 3 members, it doesn't like have an impact on the score. Like you will get a like the team will be like a team irrespective of the number of members there. For whatever the you will get scores based on the number of problems that you solve and like the difficulty level of each problem. So there'll be like certain different, like from starting from easy, medium, hard, so on. There'll be difficulty levels. So if you solve a hard problem compared to an easy problem, we will get a like a higher score added to your overall score. My team members and I tried some questions in CS again, but we couldn't get 100% marks even for simpler questions. What should we do? Yeah, in this case, I would ask what was like the reason in the sense the errors. I mean, is it like it was wrong, or is it like something like timeout? So if it is wrong answer, that means there's a problem with the algorithm. So in that case, you need to debug on why the logic in this algorithm doesn't work. And the way to do that is like a good way to do that is I think in the CS community it's called rubber ducking. So the name comes from you imagine you have a rubber duck with you and you are explaining the entire code to a rubber duck. So since a rubber duck is dumb, you explain like even the minute detail. So in that case, like you will be able to find out which what is the issue with your implementation. So this one you can do as a team as well. You like one person can explain the code that you have written to another person like through every step. So in that process, sometimes like the other person will catch a mistake, but more often than not, you will yourself catch the mistake that you have done. And if it is not a problem like that, if it is a problem like a timeout, like a issue like timeout, then the issue lies with making your code more efficient. Then you need to look at the big O notation and using different data structures and algorithms to improve it. So don't get disheartened by like not getting 100% for like even simpler questions. That I think it's a very normal thing to encounter in every person's like a competitive programming journey. So that's how everyone starts. Even like for us in the beginning, we couldn't like achieve 100% for simpler questions, but you should you should practice more, like try to debug it more, and like basically like by practicing you can improve whatever the yeah, you can by practicing you can you'll be able to like improve your skills. How do you suggest balancing academic and project work while also finding time to practice? Yeah, that's a good question. So okay, so it's a good question, but it's kind of, since it's like very subject to person, it's very hard to give a quantitative answer as well. But okay, so how we did it was like before, like a few weeks back before the competition, our team like took a meeting and tried like and like compile like the set of like the data structures, things and algorithms, things that we need to cover and each should get proficient in, and we then divided it by ourselves. And then like we set targets for ourselves. For an example, by this week, so let's say yeah, so we make the divided it by ourselves, and then we like had small target like this week. Like each person would be done by like complete these things, like these parts. So then like when you have like those little targets to hit, then you will like eventually will be like able to achieve like your overall target. And in finding time that like maybe I think there are two things that you can do. One thing is like maybe allocate a very small time each day so that it will accumulate to a long time. Or other thing is what I can think is like at the start of the week, like think of the all the things that you need to get done, and like uh, allocate it for each day with the number of hours that you think it will take. So then by doing that, by like actively doing that, you will find some time slots that are like actually free, that you can uh, um, like that you will be able to practice for practice competitive program. Uh, do you use Git during competitive programming competitions? Actually, no. Like we had a Git repo to like store like whatever the code that we wrote. Like I mean, like the algorithms that we implemented before, and like the solutions from like maybe past competitions or something like that. But during the competition, we didn't use Git uh, because uh, in the strategy that we followed was we as a group we form a probleming we solve like as a group we come up with the solution, and then only one person implements it while the other moves on to while the rest move on to another problem. So in that case, since only one person is working on it, we didn't use good Git, since we didn't need like collaboration in the sense like writing the code. Do the problems have a time limit to submit? um uh, I as I remember, there's no time limit to submit, but actually I don't remember about this very well as well. But I think there was something like if you answer a problem, um, if you answer a problem like maybe as soon as it was posted or something like that, like based on like the time that it was posted and uh, the time that you provide an answer for it, depending on how the difference between when the problem is posted and when you give an answer to that. if if I remember correctly, they consider that when giving the score, but I'm not sure, like could be wrong here. uh, uh, Actually, I am not sure about that. Yeah, like I'll give an update on the group if I find anything about that, more about that. Yeah. Does our SC syllabus has a DSA as a module? Um, so here I think you are asking about the computer science and engineering department of UOM, I think. So from my knowledge, I think they do have a data structures and algorithm module in their syllabus. And I'm from ENTC, Electronic and Telecommunications, and we also have a data structures module, which is done by a lecturer in the computer science department. Should all the team members participate together or individually? I'm not sure what the question is. If the question is whether each member should have a separate account or whether everyone participates using one account, if that is the question, then um, near the competition, they will send like the organizing team from IEEEXtreme will send like a single account with a username and a password. We have to use that account, all three, to submit questions, and like all the three people can be logged in all at once. So that's not an issue. Yeah. Yeah, I think that wraps up all the questions. Yeah. As a final remark, I'd like to mention regarding this year's registration. Like our team personally faced an issue. Like when we got registered, we didn't get an email regarding the confirmation of our registration. So like typically every year when you get registered, there'll be an email saying that you have registered. But this year when we registered, we didn't get it. And when we investigated on this, what we found was like with the help from when we inquired it about from the IEEE Computer Society, what they told was this year like each proctor needs to manually accept each team. So since our proctor hadn't like accepted our team, that's why we didn't get a confirmation. So then once we like told our proctor and when he accepted it, we got the email. So what I'd like to say is if your team got like registered but didn't get a confirmation email, that could be because your proctor has not accepted it. So please like inform your proctor and ask the proctor to accept the team so that you can get successfully registered for the competition. I think the deadline is tomorrow, so I think you better do it quickly. Yeah. Will there be any sessions after this? I think that's a question for the organizing team as well.
Yeah, definitely. So we have planned another session with like the second place winners of the IEEEXtreme last year. So it will happen on 18th of the like when 18th Wednesday. That's next week, the Wednesday. If you need any more sessions, please let us know in the like WhatsApp group or either reach out to one of our like organizing committee members. We can arrange any more if you want. Yeah, over to you. Yeah.
Okay, great. I think that wraps up all the questions. So yeah, yeah. So yeah, over to you. Yeah, over to you.
All right, thank you very much, Supun. So I think that the Supun and the team did a wonderful session there. They gave a fine introduction to what the competitions are, as well as how we should prepare for them, what we should do, what strategies we should use. Overall, it was a great session, and it interested me a lot. I'm pretty sure that everyone in the session also found it extremely interesting and is enthusiastic to participate both in Mora Extreme and in IEEE Extreme. So I encourage everyone to make sure that they have registered and prepared as teams. And this message goes out particularly to those of University of Moratuwa. We have shared in your groups a form for students who are for teams who are participating from University of Moratuwa. Please fill in the form if you want to have access to our 24-hour resources that we will be providing to all teams that are participating from University of Moratuwa. So you will be having an environment to coordinate outside with other teams, refreshments, and Wi-Fi and all that. So that was particularly for the University of Moratuwa teams. And then I would like to remind you again that the next session will be conducted on the 18th. And all of the links that were shared as well as the slides will be shared with you, are available on the chat. And if anyone still has any questions, feel free to reach out to any of the committee members afterwards. So I believe that this brings the session to an end. I would like to thank again the team for their wonderful presentation, as well as everyone participating, and finally the organizing committee for their wonderful efforts to make this session a success. So thank you. Chamaru, is there anything else that we would need to add?
Yeah, so the next it's about the next session that Sandil and his team would present. So yeah, that's the only thing that I have to say again.
All right, thank you. So I believe that wraps up this session. Again, thank you for participating, and I wish you all the best in future.
Have a good night, everyone.